Hello, in this video we're going to look at solving trigonometric equations and finding exact values of theta and exact values of the side lengths. So I would recommend you pause the video and attempt these questions, as I reckon that that's the best way that you learn. So let's check it out. Solve the following trigonometric equations for theta is between 0 and 360 degrees. Sine theta is a half. Now, solving this equation, what do we need to do? Looks a bit tricky, but it's all right. First, I need to write down, okay, what does sine theta mean? Sine theta means opposite over hypotenuse. All right, we want to solve this equation, so find the unknown value. And I realize that I have these magic triangles on my formula sheet. And I can look at it and say, okay, what angle of theta would give me 1 over 2? So you've got to choose which triangle to look at. Which triangle has side lengths 1 and 2? Well, the second one. Now, opposite over hypotenuse. Which of these angles will give me opposite over hypotenuse as 1 over 2? Well, looking at this 30, I can see that the opposite is 1 and the hypotenuse is 2. If I looked at 60, the opposite is root 3. So I know that it can't be the angle 60. It's got to be the angle 30. So I can simply write theta is 30. And you could just check it on your calculator too. I'm going to go sine of 30 is indeed half. 0.5. What about this one? Sine theta is root 3 over 2. I'll just get rid of those little things. Oops. First thing is, what does sine theta mean? It means sine theta is opposite over hypotenuse. Now, which of the triangles has root 3 and 2 in them? Well, this second one again. So in this triangle, what angle will give me opposite side of root 3? Opposite side of root 3. So opposite angle 60 is root 3. And you can just try. So I know that this should be theta is 60, but I'll just show you. If I tried out 30, that would give me the adjacent side is root 3. So that would not be quite right. And that's all it is. So theta is 60. Let's keep going. Solve the following trigonometric equations. Cos theta is a half. First thing, what does cos theta mean? What's the general rule? Adjacent over hypotenuse. Which of the triangles give me 1 and 2? Which triangle has both 1 and 2 in it? What's this second one? Now, which triangle will give me an adjacent side of 1? So which of these angles will give me an adjacent side of 1? I'm looking at that one. See that? 1 is next to the angle 60. So I will say theta is 60 for this one. Hopefully that makes sense. Okay, next one. Use trigonometric ratios to find the exact value of x. Now, first of all, we don't know, we're not given what ratio that we need to use here, unlike the last one. But we can look at the exact ratios triangles and see which one would correspond to this triangle here. So I can see that angle of 45 and then 2 equal sides here. So that would correspond to this first triangle, right? And then it's just a matter of working with what you're given. So I could actually use, I'm pretty sure, opposite over hypotenuse or adjacent over hypotenuse. So you just got to pick one. I'm going to choose sine. Sine theta is opposite over hypotenuse. And then looking at this triangle, opposite is x over hypotenuse, which is 6. And that's sine theta. But there's lots of, oh, hang on. That's sine 45. Now they want us to do this without a calculator though. Now this is it's a little bit of a tricky bit. You're going to replace this sine 45 using the exact ratios triangle that you selected. Sine 45. Now I think see how in the past few questions we worked out the value, the exact value of things? I think it was at some point we worked it out. Now, sine 45, let's look at what we could replace that exact value with. Opposite over hypotenuse. So we could replace sine 45 with 1 over root 2 equals x over 6. Simple as that. Now we could see how we got it rearranged for x. We could bring that 6 up and it would be 6 over root 2 equals x. Are we done? We are not, because we need to rationalize that denominator. So remember how to rationalize the denominator is you times by root 2 over root 2. The top will be 6 root 2. The bottom will just be 2. That's because root 2 squared. Those cancel, square and square root sign. Are we finished though? At that point, we actually have a fraction that we can simplify, right? 6 divided by 2, because that fraction sign means divide, is 3. 3 root 2 is x. And that's what we're going to do. That's our answer. So we could just write that up here. X is 3 root 2. Let's check out part B. Find the exact value of x here. Okay, well, let's just ignore those triangles for now. Let's try and write a trig equation that would link this angle with these two sides. Now we can see that we're given the opposite and we're given the adjacent. Remember that the hypotenuse is always opposite the right angle if you get confused. So opposite and adjacent, that means we're going to be using the tan ratio. Tan, and let's just substitute in our values. The angle is 30. The opposite side is x, the adjacent is 20. Now let's rearrange for our unknown value. Oh, actually, even before that, we're going to do that. Now we're going to use the triangles, okay? We know exact values for tan 30. You should recognize that angle. 30 is in this second triangle, which is great. So we're going to replace it. 30, and we're looking for tan, so we're going to say opposite over adjacent. And what have we got? Opposite is 1, adjacent is root 3, and we've got x over 20. Moving it up, we want x on its own, so let's multiply that 20 up. Are we finished? No, because we have a square root sign on the denominator. So we're going to rationalize that denominator. And it should just become 20 root 3 over 3. And you can't simplify that fraction anymore. There's no common factors. So here, x is 20 root 3 over 3. Over 3. Now, last slide, okay? We can do this. Find the exact value of theta. So before we were finding side lengths, and now we're going to find angles. So same thing really. Come up with a ratio. Look at the diagram and come up with a trig ratio equation, linking the sides with the angle. So I could pick either this side or this side. I might pick the adjacent side just for something new. So I've got adjacent and I've got the hypotenuse because that's opposite the right angle. Adjacent hypotenuse would be cos theta equals adjacent over hypotenuse. Let's substitute in cos theta is 1 over root 2. Now where do I go from here? How would I find that angle? Well, it's about looking at this and seeing, okay, I know that these are side lengths of a magic triangle. So I come over here and I think, which triangle does 1 and root 2 lie? Well, the first one. Okay. And 1 and root 2. And where are they adjacent and hypotenuse? Adjacent and hypotenuse? Well, it's going to be 45 either way, actually. So theta is 45 degrees. Okay. Now, what about this one here? Again, just try and write a relationship linking the angle with the two sides. Okay, got that. And that's opposite. And this is the hypotenuse because it's opposite the right angle. So opposite and hypotenuse are linked with sine. Sine theta is opposite over hypotenuse. Sine theta is root 3 over the hypotenuse, which is 2. And I remember that those side lengths look familiar because they're in our exact ratios triangles. So I would select this triangle, the second one, and then I've just got to work out, okay, where does sine theta equal root 3 on 2? Where is my opposite side root 3? Which of these angles would give an opposite side of root 3? Well, it's going to be theta is 60. See how root 3 is opposite? And I hope that that makes sense. And that's all that I have for you today. So I will see you in the next video.